So what we're going to talk about today is how we can use functions to explain geometric figures. So one common one that you should be pretty familiar with already is a cube. So if we had a square, we'd multiply the length times the width to get the area of the square. But in the case of the cube, we're also going to factor in how tall or how deep that cube is. So this should look pretty familiar. The area of that cube is equal to the length times the width times the depth. And with a cube, all three of these lengths should be the same. So really what we can say is that the area of that cube is equal to the width cubed. And that should look pretty familiar based on what we went over last week. So let's think about something just a little bit more complicated here. What if we had a rectangular prism this time, so it's no longer a cube, and we said that it's going to be twice as deep as it is tall. So if this was the height here, and this was the width, and again we have the depth right here, height and width are the same, but then depth is equal to 2 times the height. So then how would we figure out what the volume of that cube is, or that rectangular prism? Well, if height and width are the same, then we can say that the area is equal to height. And instead of saying width, I'm going to say it's times the height again, times the depth. And instead of depth, I'm going to use 2h, because depth is equal to 2 times h. So if I wanted to simplify that, I've got 3 h's. So once again, I can say that the area is equal to h cubed, but I've also got this 2 here. So it's h cubed times 2. We can make it even a little bit more complicated and talk about a bit of a different circumstance. So what if we had a block, just like you'd have in any city? So there's your block, and around that block they made a sidewalk. And what if I said that the block is 500 feet long? And the sidewalk is 3 feet wide. So this area right here, from here to here, is going to be 3 feet. And I know it's not drawn to scale, but you get the idea. So what if we wanted to figure out how much surface or how much area that sidewalk was going to cover? Well, I hope what you can see here is that we've got 2 squares, so we could go about this a couple of different ways. One way would be to break it up into the rectangles that make it up, so we could draw an imaginary line right here, and right here, and do the same up here. And then we'd be able to calculate the area of this rectangle and multiply it by 2, and then do the same with this one and multiply it by 2 again. But another approach we could do is we could figure out the area of the outside rectangle and then subtract out the area of the inside rectangle, or square in this case. So let's do that. So we know that the outside rectangle is going to be 500 feet plus another 3 on this side and another 3 on this side, so a total of 506 feet multiplied by itself, because this is actually a square. I keep saying rectangle, but it is a square, to find the area of that outside square. Then we could subtract from that the area of the inside square, which is 500 times 500. And that would be all well and good for this particular square, but that wouldn't help us with any other blocks of any other different sizes. So let's come up with a generic explanation for calculating the area of that exterior, that sidewalk that's going around the perimeter. So rather than saying 500, because the size of the block might change, maybe one block's a little smaller, maybe the next block's a little bigger, but the sidewalk is always going to be about the same. It's always going to be that 3 feet wide. So rather than saying 500 feet, I'm going to call this x. So f of x, or a function of x, is equal to the size of the outside square, which is x plus 6, so it's the size of this inside square, plus 3 feet on either side. So this length right here, I'll write that in red, this length right here is x plus 6. This other length, assuming that it's still a square, is also going to be that same length. So rather than write that out again, what I'm going to do is I'm going to square it. So now I have the area of that outside square. But I don't want the area of just the entire outside square. I just want to know that perimeter, that sidewalks area. So I'm going to subtract out of it the area of the inside square. So each of the sides is x long. We don't know what that is. In our first example, that could have been 500 feet, but in our next one, it might be 1,000 feet or longer. So I'm going to say minus x times x, or x squared. So now we've got a function that we can use for any length of the sidewalk, or sorry, any length of the block to figure out the area of the sidewalk. We're going to take the size of the block, and we're going to add 6 to it, and then whatever that value is, we're going to square it, and we're going to subtract from that the size of the actual block. And now we can figure out exactly how much area that sidewalk is going to be. Now we can take it a step further even still and say, what if I wanted to know what the volume of that space was? So I want to figure out how much concrete am I going to need to make that sidewalk. So let's say, and I'll rewrite our original equation, f of x is equal to x plus 6 squared minus x squared. Now right now we've got the area, the surface area. So think of area always as two-dimensional, right? We've multiplied the length by the width, but nothing in the real world is actually two-dimensional. It's all three-dimensional, so we have to add that third dimension, the height, in. And just for easy math, I'm going to say that, we've been talking in feet, I'm going to say that that sidewalk is 6 inches thick. That's going to be a really thick sidewalk, but it'll be easy for us to see the math there. So let's say that that sidewalk was 6 inches thick. Well, all our other measurements are in inches, so let's convert 6 inches to feet. So 6 inches divided by 12 inches is equal to 1/2, and now we know how large in feet it is. So now we know how tall the sidewalk is, and we know the area of that sidewalk. So let's figure out what the volume would be. F of x is equal to x plus 6 squared minus x squared. So that's that outside square minus the inside square. So now we know the area of just the perimeter, just the sidewalk, and we know it's going to be 1/2 foot thick. So we're going to multiply that whole thing by 1/2. And if you think about it for a minute, multiplying by 1/2 is going to be the same as dividing by 2. So now once again we have a function that lets us put in any value for x. So if you were trying to figure out how much concrete is it going to take me to make this sidewalk, all you'd have to do is put in the length of that block, x, and this function would tell you. So this is just one of the many ways that we can apply functions to geometry and use it to find volumes for real-world shapes.